Hi everybody. The purpose of this video is to go over section 3 of chapter 2, and we will be discussing quadratic functions. This will be the first of 3 videos that go over this specific section. In this section, we will introduce the idea of a quadratic function. We will describe the quadratic function in both standard form and vertex form. We will talk about how to find the vertex form of a quadratic function from its standard form and vice versa. And then in follow-on videos, we'll talk about how to figure out quadratic functions with technology and some applications relative to business and economics. Okay, and this is our first definition. Let a, b, and c be real numbers with a not being equal to 0. Then this function f of x, which is equal to a times x squared plus b times x plus c, is a quadratic function, and the graph is a parabola. And this is also known as the standard form of a quadratic function. Now, why did we say that a cannot be 0? Well, if a was 0, then this term would go away and we would have a linear function, a function whose graph is a straight line. And notice the primary difference between a linear function and a quadratic function. The linear function is a straight line. Hence the word linear function is a first degree function. This function has some shape. Matter of fact, it has a shape of a parabola. It is also what we call a second degree function because it has a term that has a degree of 2. And as a consequence, we have some shape. And what you might guess is the higher a degree, the more shape you get. But when you only have 2 degrees, you're going to have something. You are going to have something that basically turns once, or a parabola. Okay, the other form of a quadratic function is what we call the vertex form, and it looks like this. It's going to be a times the quantity x minus h, the entire thing squared, plus k. Now notice that this is a perfect square. Okay, and also notice that the a term here is the exact same parameter that is here, or the exact same coefficient that is there. Okay, so it's the exact same thing here. And also the vertex, the hk, the parameter h and k, describes the vertex of the parabola. Specifically, it describes this point here and that point there, where the x coordinate is h and the y coordinate is k. So as a consequence, if you actually have the vertex form of the parabola, if you actually have the quadratic equation in vertex form, you can figure out more about the parabola than you can in standard form. The only 2 things standard form will tell you is if the parabola is going to be going upward when a is positive or downward when a is negative, and it will also tell you where a crosses the y-axis. In the vertex form, we get the same information from a, but we also know where the parabola turns, or where the vertex is, or where the maximum or the minimum is, depending upon whether the parabola is going up or down. So the vertex form happens to be a little more intuitive. And here we go. Here's the vertex form of a parabola. Now here is the case where a is negative. When a is negative, the parabola will always open down, and the vertex, the point where it turns, goes from an increasing direction to a decreasing direction or vice versa, is always going to be the maximum. This is a particular example of f of x being equal to negative 2 times the quantity x plus 2 squared plus 3. And the vertex is going to be at the coordinate negative 2, comma 3. And since a is negative, the vertex will always be a maximum. And there's also another parameter that we have for parabolas, and that is the axis of symmetry. And that basically tells you that vertical line that divides the parabola in half. For another example, we have f of x is equal to x plus 2, the entire quantity squared, minus 3. In this particular case, a is equal to 1, a positive number. So now the parabola opens upward, and the vertex is now a minimum. So when a is positive, the parabola opens up, and the vertex is a minimum. When a is negative, the parabola opens down, the vertex is a maximum. You want to be comfortable with that idea. Once again, since h is negative 2 and k is negative 3, the vertex is at the corner negative 2, 3. And since h is negative 2, the axis of symmetry is the vertical line x equals negative 2, because that vertical line divides the parabola in half. Okay, so let's just talk about some of the properties. We've actually gone over this in a little bit of detail. Remember, if a is greater than 0, then the parabola opens up, like this one right here, okay? And the vertex is always going to be a minimum. If a is less than 0, then the parabola will open down, and the vertex, which will always be a maximum. And the vertex is going to be found by the vertex form of the equation, basically by figuring out what h is and figuring out what k is. The quadratic function will always have exactly one y-intercept. Every quadratic will have exactly one y-intercept. Now, the x-intercepts, if they exist, can be found by the quadratic formula. This is the quadratic formula. You do not need to memorize it, but you do need to know how to use it. And it will also be a benefit for you to also know how to find the x-intercepts, perhaps not using the quadratic formula, because that can be a little involved, but also using technologies such as this graphing application right here. Now, talking about the quadratic formula, this is the quadratic formula. And these are the a's, b's, and c's that you would find if the quadratic equation was expressed in a standard form, or the function was expressed in a standard form. And then what you do is you knock these things out, and what you will find is if this term, which we call the discriminant, if it is greater than 0, then there will be two intercepts. If this term happens to be equal to 0, then that basically means that your quadratic function is a perfect square, and you will have exactly one x-intercept. And if it's less than 0, which is pretty much what you have right here, then no intercepts exist. So once again, if your discriminant is greater than 0, that will be a curve that looks exactly like this, and you will have two x-intercepts. If it is equal to 0, it will intersect exactly at one point. If it is less than 0, then you have a curve that looks like this, or its reflection down here, and there are no real valued x-intercepts. There are x-intercepts, but they happen to be complex numbers. Quadratic functions always have symmetry, and there always has symmetry around the vertical line x equals h. In this particular case, h is negative 2, and we have x is equal to negative 2. The domain is the entire real line, and the range, remember the range is all the values, all the y values that the function can put out. And for this particular function, it can put out all values as low as negative infinity and as high as k. And this is a case where a is less than 0. So if a is less than 0, the range is going to be the half open interval from negative infinity, the little typo there, to k. And if a is greater than 0, the range is going to be from k to infinity, because if a is greater than 0, then your parabola opens up. Okay, so suppose that I gave you the standard form for a quadratic function. So suppose that I gave you f of x is equal to ax squared plus b times x plus c, where a, b, and c are some numbers. How can you take the function from the standard form and convert it to a vertex form? Well, there are two ways. The first way is the technique called completing the squares, which I'm going to show you in an example. But it basically takes advantage of the fact that this expression is a perfect square and can be expanded into this. So the idea behind completing the square is you start with this, you add whatever you need to make a perfect square, and then you subtract it again, and then you can substitute this expression for that, or this expression for this, depending upon the two that you're doing. I know it sounds kind of complicated, but maybe it'll seem a little more clear when I do one example. The way that I expect you to do it, and you'll notice that this is more simple after we go through the next two examples, is through parameter matching. Now, it turns out that h in the vertex form is equal to negative b over 2a. So all you need to do is remember that the h, and the h right here, is equal to negative b over 2a. So if you know what a, b, and c are, you can use a and b to figure out what h is. Once you figured out what h is, then k is nothing more than f evaluated at h. So all you would need to do is compute f of h, which would be equal to a times h squared plus b times h plus c, and that would give you what k is. So then h would go into here, and then whatever you get for k would go into there. All right, and let's see what this looks like in an example. Okay, so here we want to find the vertex square of this function by completing the square. Okay, and this is pretty much the way completing the square works. The first thing that you want to do, you want to factor out a. Okay, and if you do, you are going to have f of x is equal to negative 0.25 times the quantity x squared plus 8 minus 8. Oh, mistake there. That's not right. Let's fix that. That'll be x squared plus 8x minus 8. Okay. Now we want to create a perfect square. Okay, now to do that, what we want to do is identify the linear coefficient, which in this case is 8. We want to divide it by 2, which will give us 4. And then we want to square it, which will give us, well, either 4 squared or 16. Now, what I want to do now is I want to add 4 squared to this particular equation. And if I do, I'm going to have that this is going to be equal to negative 0.25 times the quantity x squared plus 8x plus 4 squared. Now, remember, I don't want to change the function, so if I want to add 4 squared to this, I need to subtract 4 squared from this, or namely 16. Minus 8. So what did I do? Well, effectively, all I did here was I added 0 to it by adding and subtracting from it 4 squared. And I did one side symbolically, and I evaluated on the other side, and hopefully that will come clear to you in just a second. Okay, now also notice that this portion right here is a perfect square. It has to form x squared plus 2ax plus a squared, where a happens to be 4. Okay? So this has the form of a perfect square, and what we have seen in the previous screen, that screen right there, I can write that as x plus a, the entire thing squared. What I want to do now is place grouping symbols around that perfect square. And if I do, I'm going to have something that looks like this. Negative 0.25 times, okay, here's my grouping symbols around the perfect square, x squared plus 8x plus 4 squared minus, and now I can combine these, which will give me 24. Okay, at this particular point, I can now substitute, and I can substitute my binomial version for the perfect square. This is my trinomial version, 3 terms, and I want to substitute now the binomial part. And notice that that is going to be x, right? X plus a, the entire thing squared. All right, so I just make that change, and over here I still have minus 24, and all of this is going to be multiplied by negative 0.25. So basically, I basically substituted with binomial version. And then finally, all I need to do is multiply out the 0.2, multiply back in the 0.25 using the distributive property. And I'm going to do that up here since I'm kind of running out of space. And that will give me that f of x is equal to negative 0.25 times x plus, and that really shouldn't be an a, that's a mistake on my part. That should be a 4. So let me go ahead and change that to what it should be. Let's remember x plus a is 4 in this particular case. So I'm going to have over here negative 0.25 times the quantity x plus 4 squared, and then it's going to be negative 0.25 times negative 24, which will give me a plus 6. So that is how you can convert from standard form to vertex form using completing the square. Now, I know for this particular case, this sounds kind of daunting. Actually, I can assure you, if you practice it a few times, it'll be a piece of cake. However, you don't need to do it that way. I just wanted to give you appreciation for the intensity of it before we do it the way that I expect you to do it anyways. Okay. So here's example 2. It's just like example 1, except here I say, or here you're asked to find the vertex form of the following function. Hey, it's the exact same function, but I don't tell you how to do it. You can do it any way you want. Okay. Now, the way that I would expect you to do it in this particular case is not using completing the square, but to use parameter matching, what we are doing here. Instead, I want you to take advantage of the fact that the vertex form is going to be f of x is equal to negative 0.25, that's a, times the quantity x minus h squared plus k. And all you need to do is figure out what h is and figure out what k is. Okay, well, I've already told you that. H is going to be negative b over 2a. It's right here. Okay? Well, here's b, and there's a. So h, which once again is negative b over 2 times a, is going to be equal to the negative of, well, negative 2, divided by 2 times negative 0.25. Okay, well, that is going to be equal to positive 2. And then 2 times negative 0.25 is going to be negative 0.5, which is going to give you negative 4. So h is negative 4. Okay, well, fine. What is k? K is going to be equal to f evaluated at h. In other words, it's going to be equal to f evaluated at negative 4. All right, well, here's our definition for f. That is going to, so we're going to have, substituting negative 4 in for x, you're going to have negative 0.25 times negative 4 squared minus 2 times negative 4 plus 2. All right. Negative 4 squared is 16. Negative 0.25. So we're going to have negative 0.25 times 16. Negative 2 times negative 4 is positive 8 plus 10. Plus 2, sorry. All right. Negative 0.25 times 16, well, that's basically 16 divided by negative 4. That is going to give us negative 4. 8 plus 2 is 10. Negative 4 plus 10. And that is going to be equal to 6. So k is equal to 6. So with that in mind, the vertex form of f is going to be equal to negative 0.25 times x minus negative 4, which is x plus 4, the entire quantity squared, plus 6. That's what we get. Ironically, that's what we got before when we completed this. And ironically, that's what we got before when we completed the square. Now, in this particular example, we want to analyze a quadratic equation, which basically means trying to find all of these particular items. And I might need to go to OneNote to do some of this. We'll just kind of see how it goes. And the first thing is to find the vertex form for this particular equation. Okay, because both the vertex form and the standard form will be helpful in solving these problems. Okay, so let's go ahead and do that. Remember, the vertex form is f of x is equal to a, which in this case is going to be 1. So I'm not even going to bother doing that, times x minus h, the entire thing squared, plus k. And we know that h is equal to negative b divided by 2 times a. Well, a is equal to 1, okay? And b is equal to negative 8. So that is going to be the negative of negative 8 divided by 2 times a. Let's flip it once again. A is equal to 1. And that is going to be 8 divided by 2, or 4. Okay, now we know what h is, we can figure out what k is. K is going to be f evaluated at 4, because that's what h was. And that is going to give us, well, 4 squared minus 8 times 4 plus 12. That is going to be 16 minus 32 plus 12. That will be equal to negative 16 plus 12, and that will give us minus 4. So we have that k is equal to minus 4, and h is equal to 4. And that means we can rewrite the vertex form for this is going to be x minus 4, the entire thing squared, minus 4. I forgot the minus sign right there. Okay, now this question brings us back to section 2, which is what is the relationship between f of x and y is equal to x squared. Well, notice here that in f of x we have a shift in the argument, and that is basically a horizontal shift. And if it's a shift, and if the shift is negative 4, that is a shift to the right. So we have a right shift, 4 units, and then this one is outside of the argument, so this would be a vertical shift, and that would be a downshift, or a shift down, and that would be 4 units. Another way to look at the shift is basically just to plot it using an application that I like to use called GeoGebra.org right here, or you could actually go ahead and use your graphing calculator. Now here is y is equal to x squared, okay? And here is our function f of x. And notice that we have, this is our shift to the right, 4. 1, 2, 3, 4. And then this is our downshift, 4. 1, 2, 3, 4. So that's the relationship between the two. Once again, this is the shift to the right, and this is the shift down. Now the next question is, what are the y-intercepts? Now that is the one thing which can be easily found using the standard form of our function. And how do we find the y-intercept? Hey man, we just set x equal to 0. So we want to evaluate f of 0, and that will be equal, well, 0 minus 8 times 0, which is 0, plus 12, which will give us 12. So our y-intercept is 12. Now for the x-intercept, there's a variety of ways to do that. One is to use the quadratic formula. The other is just to plot it and see what you get. And if you do, you will find out that the x-intercepts are 2 and 6. And you can also do that on your graphing calculator. Another way to do that is to take this is to take the vertex form, this form right here, and set it equal to 0 and solve for x. So let's go ahead and do that. That will give us that 0 is equal to the quantity x minus 4, the entire thing squared, minus 4. Now, what I can do, and to do this, we want to solve for x now, right? So what I can do is get all the terms without the x on one side and the term with the x on the other side. So I want to add 4 to both sides. And actually, let's go ahead and do this in another application. I'm going to bring up OneNote, and we can do it there. Okay, so here we are, and here's our question. Once again, we can actually figure out what the x-intercepts are by setting f of x equal to 0, by setting y equal to 0 and solving for x. So that means solving the equation 0 is equal to x minus 4, the entire thing squared, minus 4. And we want to go ahead and solve for x. So the next thing we can do is we can add 4 to both sides of the equation. And if we do, we will have that 4 is equal to x minus 4, the entire thing squared. Once we have done that, we can take the square root of both sides. We can take the square root of 4, and we can take the square root of 4. Remember, the square root of 4, or the square root of, or we can take the square root of x, and the square root of x minus 4, the entire thing squared. Now remember, the square root of 4 are all those numbers that, if squared, will produce for you a 4. And that is basically plus or minus 2. 2 squared is equal to 4, minus 2 squared is equal to 4. And then the square root of this is going to be equal to x minus 4. So we are down to this particular equation. Okay, we can actually get rid of the grouping symbols. I don't know why I put those up there now that we took the square root. And that's what we have. And now we can go ahead and solve for x. And then we will have that x is equal to 4 plus or minus 2. So x will either be equal to 4 plus 2, which is 6, or x will be equal to 4 minus 2, which is 2. And these are the x-intercepts. And that kind of makes sense because that is where this curve crosses the x-axis, 2 and 6. Okay, next question is, what is the vertex of the graph? Well, remember, the vertex form of this particular equation, that's up here, I'm going to write it again, is f of x is equal to x minus 4, the entire thing squared, minus 4, or x minus h, the entire thing squared, plus k. And there, of course, there's an a there, but a is equal to 1. So the vertex is always going to be h comma k. So in this particular case, the vertex is going to be, well, 4 minus 4, 4, and then k is also is minus 4. So the vertex is going to be 4 minus 4. Once again, does that make sense? Of course it does. There's the vertex, 4 minus 4. Okay, does the graph have a maximum or a minimum? Now remember, if a is greater than 0, we have a minimum. If a is less than 0, the vertex is a max. In this case, a is equal to 1, that's greater than 0, we have a minimum. And what is that maximum, or what is that minimum? This is the minimum. The k value is the minimum right here. So the minimum is going to be y is equal to negative 4. And then what is the range? Well, if that's the minimum, that means that y cannot take any values lower than that. So the smallest value that y can take is negative 4. And since a is greater than 0, it's going to go all the way up to infinity. That's the range. The half-open interval from negative 4 to infinity. Remember, whenever you have an infinity, you need to have a parenthesis, not a bracket. And that brings us to our last example. Some of your homework questions will involve, you'll be given a graph of a quadratic, and then you will be asked a few questions. And here we go. Here's our graph. First question is, what are the y-intercepts? Well, there can only be one. And all you got to do is basically see where this graph crosses the y-axis. It crosses right here. So the y-intercept is y is equal to negative 4. No, y is equal to positive 4, sorry. Okay, state the x-intercept. Well, that are those values where the graph crosses the x-axis, and that occurs at negative 1 and 3. So the x-intercepts are x is equal to negative 1 and x is equal to 3. What is the vertex? Well, the vertex is basically where the graph turns, which is right about here, or the tip of the graph, which is that particular point. Now, how do you read that point? Remember, we always read the horizontal component first, or the x component. That is going to be 1, 4. So the vertex here is 1, 4. That's what that point is right there. Does this graph have a maximum or minimum? Well, it's pretty clear that this sucker has a maximum. What is the value of that maximum? Well, if they want to know what the value is, they basically want to know what the y-coordinate is, and the value of that maximum is y equals 4. And that basically means that we made a big mistake right here. The y-intercept, 1, 2, 3. The y-intercept is y is equal to 3, not y is equal to 4. Obviously, I had some counting issues when doing that one, but there it is, 1, 2, 3. Sorry about that. Okay, and then coming back to here, stay in the range. We have a graph that's going down, and the range is going to start at negative infinity. And the highest value that this graph can take on is 4. So it's going to be the half open interval from negative infinity to 4. And then, once again, since I kind of screwed this up, I've beaten this course just one more time. Notice that the y-intercept is y is equal to 3. And that is all that I have for this particular video. If you have any questions, please feel free to contact me. Stay tuned for the other 2 videos on this particular section. This is Bob Oil, signing off.